Today we're going to take a look at vectors when we have three forces acting on an object. So let's take a look at this problem. The magnitude and true bearing of three forces acting on an object are given. Find the magnitude and direction of these forces. So essentially what we're going to want to do is add up these three forces working on an object. So let's get a general idea of what's going on first. Okay? So first off, we have one force that is 8 newtons at 300 degrees. So if we rotate around 300 degrees from in our true bearing, 300 degrees is here. I'm going to call that force 1. Remember, it's 8 newtons. Then we have a 12 Newton force going in 45 degrees. So 45 degrees over 12 newtons, a little bit longer. We're going to call that force 2. And then we have a third force that is going 120 degrees for 6 newtons. We're going to call that force 3. If we want to add these up, we can do tail to head like we've done before. So what we would do is we would take force 1, add on force 2, a little bit longer. Okay, I'm trying to mimic this angle here. And then force 3. Our resultant is this force right here, R. And our job is to figure out the magnitude, which is essentially the length, and the direction angle. Now, we're going to find this angle here eventually, but those are the two things that we're going to want to find. Let's think about this for a moment. We're moving left and up, right and up, down and right, and we end up here. We have a lot of left and right movements, up and down movements, but we end up right here. So one of the things we can do to find out what the resultant is to add up all the horizontal movements and the vertical movements, or add up all the x distances and the y distances. So essentially, we can find this x distance here and this y distance here. And when we have that, we can use that to find r, because the magnitude of r is going to be equal to the principal square root of the x distance squared of the resultant plus the y distance squared of the resultant. We have a right triangle right there, so that makes sense. We'll talk about the angle in a moment, but let's focus on finding these x and y distances here. So let's find out what the x values are for each one of these vectors. So what we're going to do is find all the angles between this vector and the x-axis, because that'll help us out, and I'll explain in a moment. So if this is 300 degrees, then this reference angle, if you remember, is really just going to be 30 degrees. So let's think about this. This is a right triangle. So our x distance for force 1 is really the magnitude of force 1, which is 8, times the cosine of the angle, which is 30 degrees. The only thing we have to think about is we're going to the left, aren't we? So that means our distance is to the left or negative. Let's take a look at the next one. Our x for force 2. Okay? Now, again, we make our x distance here, which we need this angle right here. Well, because that's 45, this is also 45 degrees. So our x distance is going to be our magnitude, or 12 times the cosine of 45 degrees. And then here, we have our right angle here. We're going to the right. So again, our x for force 3 is going to be positive. So our magnitude is 6 times the cosine of this angle here. Oops, forgot to find that. Well, if this is 120, then this angle right here is 30 degrees. I don't know if you noticed, but coincidentally, this angle and this angle are opposites. So these two forces are actually in this particular problem working against each other. Okay? So we can go ahead and calculate those, but let's take a look at our y. So our y for force 1 is this distance here. And if we use our right triangle trig, that is 8 sine of 30 degrees. We're going up, so it's positive. Our y for force 2 is going to be our magnitude of 12 times the sine of our angle, 45 degrees. And again, we're going up with force 2, so we're positive. Our y for force 3 is our magnitude, which is 6 sine of 30 degrees. But don't forget, this force is acting down now, so that's negative. So, when we put these things together, our x force of the resultant will be negative 8 cosine of 30 degrees plus 12 cosine of 45 degrees plus 6 cosine of 30 degrees. And we can go ahead and type that into the calculator, but when we do that, we get approximately 6.77. Now, let's take a look at our y resultant. We're going to add those up, all of our y's now. 8 sine of 30 degrees plus 12 sine of 45 degrees minus 6 sine of 30 degrees. And again, we can go ahead and plug that into our calculator, and when we do that, we get 9.48. So the resultant of adding all these forces up means we're going to go in the positive direction, 6.77, and in the positive direction for y, 9.48. And if you look, that kind of matches our picture. Right and then up. So now, can we find our resultant force? Absolutely. The resultant is going to be the principal square root of 6.77 squared plus 9.48 squared. Or the resultant force turns out to be a magnitude of 11.6 newtons. Not too bad. And again, we're using right triangle trig here, just looking at our pictures individually. The one that people have the most difficulty with is, how do we figure out this direction? We want to figure out this angle right here, because that's true bearing. Well, you notice we have a right triangle here. Let's call this angle right here alpha. How is this y and x related? Well, think back to right triangle trig. The tangent of alpha equals the y resultant divided by the x resultant. Your right triangle trig. So the tangent of alpha equals our y, which was 9.48, divided by 6.77, or alpha equals the inverse tangent of 9.48 over 6.77, or alpha works out to be approximately 54 degrees, which is great. But remember, we want our true bearing, which comes all the way from north. So once we know this angle here, since this is 90, theta in our picture, and that's going to be key when you do these problems, drawing an accurate picture, is going to be 90 degrees minus 54 degrees, or theta equals 36 degrees. So our resultant force will have a magnitude of 11.6 newtons and a direction of 36 degrees. Hopefully this helps you out when you're doing problems similar to this. Let me know if you have questions.